Welcome to this tutorial that explains some fundamental concepts of digital communications. Communications have become a central element of our lives, both in a professional and private sense. We scroll among unlimited streams of video content on the TV, we play computer games with our friends, and we participate in video conferences with colleagues on other continents. Where telecommunications once just meant telephony, today streaming services, internet access, data sharing, and video communications have become mainstream, making up the vast majority of all the information transported over the electronic web spanning the Earth. The relentless need for more communications capacity is one of the clearest technical trends today. The users want higher quality videos, faster response times, and better access to data, all factors that drive the demand for more and more bandwidth. Today, the consumer wants to watch streaming video in HD quality, requiring that megabits per second of data is sent to each individual home and screen. And your company wants to swap the content of entire disk drives with terabytes of data between sites in seconds rather than in days. The traffic growth has been exponential, and this will continue. Technological innovation and mass production have gradually reduced the cost of each transported bit, and a lower bandwidth cost spurs the innovation of even more bandwidth-hungry applications. The shift towards higher capacity communications networks is in a positive feedback loop, and it will continue to roll on for a long time. How is all of this information transported? The largest networks are public networks, run by communication service providers and network operators, which sell bandwidth capacity and related services to their customers. These networks often have a hierarchical structure where traffic from many users is aggregated and then transported over common long-distance connections. There are also many specialized communication networks used internally within organizations. They may be installed for company internal business systems, for example, in the financial industry, or to connect data centers operated by a service provider. Such networks are often referred to as private networks, although they may actually lease their transmission capacity from a public network. For both public and private networks, optical transmission techniques, that is, data is sent as light over an optical fiber, have become the dominant technology. Optical fibers can carry much more bandwidth than copper wires or a radio link, and they are less susceptible to interference and signal degradation. Optical fibers are deployed in many ways. Fiber cables are buried underground, strung on overhead poles, and spun around high-voltage power lines. The fiber is sensitive to physical damage and does not tolerate sharp bends. Hence, it must be protected from the outside environment by being deployed in ducts or some other type of physical shielding. The links between sites are normally created by installing fiber cables, each cable containing 10 to 20 individual fibers, and sometimes also copper wires for the power supply of intermediate amplifiers. Initially, only some of the fibers are used or lit, and the rest are available for future expansion or leased to other users as dark fibers. But how is the information, the data, transported over the fiber? To understand that, we need to know more about analog and digital signals. The sounds and images we perceive with our ears and eyes are analog signals. They vary in strength and intensity in a continuous way. However, processing and transmission of the signal is best done in digital format, having the information represented as numbers, and ideally as binary numbers. That is, just by having the values 1 and 0, or on and off. The analog signal is therefore sampled at certain intervals, and the sample values are converted to numbers, indicating the strength of the signal at that point in time. The numbers can then be encoded, which gives us a digital signal representing the original incoming analog signal. As indicated in the right-hand side diagram, such a signal consists of periods of on and off, or ones and zeros, which is the format needed for efficient storage, processing, and transmission of data. Each on or off signal is called a bit of information, and when we say that a link has a capacity of a megabit per second or a gigabit per second, we are talking about how many millions or billions of such bits that can be transported over the link per second. Having the digital signal, we can now create an optical communications link using the dark fiber we have buried or leased. The digital signal, coming from a router or switch in electrical format, must first be converted into an equivalent light signal, sent over the fiber, and then converted back to an electrical signal at the other end of the fiber. This optical communications link can transfer one channel of information in one direction. but we can achieve more channels and increase the overall link capacity by multiplexing multiple channels over the same optical fiber, which is the subject of this entire tutorial series. Optical transport networks are the fundamental building blocks of all types of digital communication networks. The capacity and reliability of the optical fiber, combined with the cost-efficient multiplexing possible, has proven to be the ideal answer to the ever-growing demand for bandwidth. This ends this tutorial. To learn more about optical communications, just continue with the next tutorial in this series.